Picture this. You're dealing with a massive petrochemical fire or a major emergency on a sprawling airport runway. In those intense, critical moments, a standard fire truck simply isn't going to cut it. You need a specialized, heavy-duty frontline defender, a machine perfectly engineered to carry up to 16,000 liters of water and highly aggressive foam concentrates. But how do you actually procure and build a specialized beast of that scale completely from scratch?
Welcome to The Explainer. Today, we're unpacking what is essentially a dynamic global blueprint for sourcing heavy-duty fire apparatus. Specifically, we're diving into how fleet managers and procurement heads are evaluating, customizing, and actually procuring these massive foam fire trucks from Chinese original equipment manufacturers, or OEMs. Our goal today? To show you exactly how to navigate this whole process without ever compromising on operational reliability or your budget.
Here's how we're breaking this down today. First, sourcing high-stakes apparatus. Then matching the chassis to your operations, looking at tanks and foam proportioning, auditing those factory capabilities, and finally, mapping out the global procurement workflow. Let's get right into it.
All right, Section 1, Sourcing High-Stakes Apparatus.
So here's the deal. The Chinese specialized vehicle market has absolutely massive production capacity, right? But as a buyer, you've really got to look way past that initial price tag. True success in global sourcing is kind of a high-wire act of engineering and economics. You have to balance your budget constraints with absolutely uncompromising operational reliability. You're evaluating if a supplier can take a rugged platform, integrate super precise systems, and still ensure the final vehicle fully complies with the strict regulations of your specific destination country.
Moving on to Section 2, Matching Chassis to Operations. Your core engineering choices literally start from the ground up. The chassis dictates the whole shebang, your maximum payload, your off-road mobility, and your long-term serviceability. For instance, if you're outfitting for urban streets or standard industrial parks, a 4x2 drive holding 3,000 to 8,000 liters from a brand like Foton or FAW is right on the money. But what if you're responding to a forest fire or a mining site? You'll absolutely need a 4x4 for that rough terrain. And for the true heavyweights, think petrochemical facilities or major airports, you're looking at a massive 6x4 drive. We're talking capacities over 16,000 liters, built on beasts like the Cinetruck Hawa or the Isuzu Giga. You really have to match these drive types to your exact operational environment right from your initial request for quotation.
Now here is a massive procurement trap that is entirely avoidable. Before you lock in any chassis brand, you absolutely must confirm your local transport authority's emission standards. Whether that's Euro 2, 5, or 6, if you get this wrong, your multi-million-dollar fleet is going to get permanently stalled at customs. No way around it. Same goes for the steering configuration. You need to explicitly state if you need left-hand or right-hand drive. These major chassis brands build specifically for export markets, sure, but they need to know your exact requirements up front.
Okay, on to Section 3, Tanks and Foam Proportioning.
The way a factory approaches fabricating these tanks actually tells you pretty much everything you need to know about their overall quality. You see the primary water tank? Well, that can often be made from high-quality carbon steel, provided it has some advanced anti-corrosion coatings. But the foam tank is a totally different story. Foam fire trucks handle highly aggressive, incredibly corrosive chemical concentrates. Because of that crazy chemistry, the foam compartment literally demands superior materials. We're talking high-grade stainless steel or highly specialized linings. If a manufacturer tries to cut corners here, the chemical concentrate will literally eat the tank from the inside out.
So how do we get that foam to the fire? That's where the foam proportioner comes in. And it's honestly a marvel of engineering. Imagine the extreme heat and sheer chaos of a chemical fire. Right in the middle of all that, these systems use mechanically linked or electronic valves to accurately mix that aggressive concentrate with the water. Usually it's at a super strict standard rate, like 3% or 6%. The stakes here are literally life and death. These proportioning valves have to maintain exact, accurate mixing rates, even as pump pressures are fluctuating wildly during an operation.
And driving all of those intense fluid dynamics is the power takeoff, or PTO system. Simply put, this mechanical system steals rotational power from the truck's engine to drive the massive fire pump. When you're reviewing a manufacturer, you've got to rigorously verify the pump's rated flow capacity, whether you're measuring in liters per minute or gallons per minute. Furthermore, check, do they use proven, reliable domestic pumps, or do they have the engineering chops to integrate specific imported brands if your local regulations require it?
Next up, Section 4, Auditing Factory Production Capabilities.
Look, not every assembly plant that bolts trucks together is actually qualified to build specialized frontline firefighting gear. Consider this your strict, non-negotiable visual checklist when auditing an OEM. First, welding standards. A 16,000-liter tank takes a severe, violent beating from dynamic loads when racing to a scene. You can't just eyeball a weld. You need non-destructive testing, like ultrasonic or radiographic checks, to literally look inside the metal. Second, electrical and plumbing. With all the complex electronic valving, everything must be neatly routed, clearly labeled, and super accessible for a mechanic working in a hurry. Third is export compliance. Does the factory provide proper global logistics documentation, electrical schematics, and, crucially, manuals in clear English? If your local fleet crew can't read the manual, they definitely can't maintain the truck. Plain and simple.
And finally, Section 5, the Global Procurement Workflow.
You know, you might be totally surprised to learn that the standard minimum order quantity, the MOQ, for these highly customized, heavy-duty vehicles is often just one single unit. Yep, just one. Because they're meticulously built to order based on your specific fleet requirements, you don't have to commit to a massive fleet of 50. That being said, if you do sign a multi-unit contract, it's going to significantly drop your per-unit shipping and your upfront engineering design cost.
So what does this actually look like in practice? Here is the exact chronological workflow you'd experience with a seasoned platform like CN Special Vehicle. Step 1, technical parameter submission. This is where you hand over your required capacities, your preferred chassis, and even stuff like your destination's climate conditions. Step 2, engineering CAD sign-off. Nothing, and I mean nothing, gets built until you review those general arrangement drawings and sign off on the precise layout. Step 3 is chassis allocation, which is basically the factory ordering the bare truck. Step 4, superstructure fabrication. This is the intense heavy lifting, welding tanks, mounting pumps, and integrating the piping. And finally, Step 5, factory acceptance testing, or FAT. The truck goes through rigorous pump pressure and road tests before it ever leaves the facility. Let's put that onto a calendar. From day 1 of your technical sign-off, you're looking at a total lead time of around 60 to 90 days. The biggest variable? That's usually the first 30 to 45 days, which is heavily dependent on the commercial chassis brand's own production backlog. But once that chassis hits the specialized factory, you're looking at another 30 to 45 days to wrap up the superstructure, get it painted, and completely crush those crucial factory acceptance tests.
Okay, so it passed testing. Now for global logistics. How on earth do you ship a behemoth across the ocean? Well, experienced suppliers handle this by utilizing heavy-duty RoRo, which stands for roll-on/roll-off shipping. Basically, your fully assembled, ready-to-work fire truck is driven directly from the port right into the ship's massive cargo hold. And if your destination port doesn't have RoRo service, no problem. They'll pivot and use specialized flat rack containers on bulk cargo ships to make absolutely sure it reaches your operational fleet.
I really want to anchor everything we've talked about today with this vital quote on quality benchmarks. NFPA 1901 for automotive fire apparatus, and ISO 9001-2015 for OEM production. When you're vetting any overseas manufacturer, these two globally recognized standards have to be your absolute North Stars. NFPA 1901 ensures the pump and tank integration meets the absolute highest safety and performance criteria, while ISO 9001 guarantees the factory's production lines are managed with hardcore quality control. These aren't just acronyms, they're literally what separate the truly top-tier assembly lines from the rest of the pack. Well, we've covered a tremendous amount of ground today, from matching drive types to demanding non-destructive weld testing, right through to understanding global shipping timelines. As a fleet manager, you demand that your vehicles perform flawlessly under literally the most extreme, hazardous conditions imaginable. But I want to leave you with this one final provocative thought. Is your procurement strategy as rugged as your frontline fleet? Give that some thought. Thanks for learning with us today on The Explainer.